Hello, Algebra 2, and here we are with the first lesson of the year, Operations with Matrices. We're going to look at adding and subtracting first, and we'll move on to multiplying at the end. First off, you guys probably haven't ever used matrices before. It's just another way to store or group, gather information, data points, numbers. Okay? And in order to add these two together, they need to be the same size or same dimensions. And then you're just going to add or subtract the numbers or elements in the matching spots. So in the first one that's already done for us, we take the top left corner with the other top left corner. 1 plus 5 is 6 to get our answer for the top left corner. Top right corner, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. Okay? Let's see if you can do the next one on your own. Go ahead and push pause and give it a go. Welcome back. Let's see how you did. Okay, it might be a little extra or too much work, unnecessary work for you to do one of these every time. So after you do it once or twice, you should be good to go. 2 plus 1, we should have 3 in the top left corner. 3 plus 2 for 5 in the top right corner. 4 plus 4 is 8 in the bottom left corner. And 1 plus 5 is 6 in the bottom right corner. Okay, same thing with subtraction here. 7 minus 2 is going to give me 5 in the top left corner. 8 minus 1 is 7 in the top right corner. 9 minus 7 is going to be 2. And 10 minus 2 is 8. Okay, subtraction, not too bad. Ooh, now we have a different size. They're still the same size. Okay, it's a little bit larger. Still the same idea. Spot to spot. We also have some negative numbers in this one, which makes it more fun. So, top left corner, 12 minus 8 is 4. Top middle, 4 minus negative 1. Minus a negative turns into plus positive. So that should be a 5. Negative 8 minus 2 more is negative 10. Bottom row, 2 minus negative, so plus 3, is going to be 5. 7 minus 5 is 2. And 3 minus negative, so plus 1, is 4. Yeah, those minus negatives get tricky in there. Especially early in the year, it's really easy to make a mistake there, so be careful. Let's have you try the adding one on your own. Go ahead and push pause on the video and try that one by yourself. Welcome back. Let's see how you did. So adding usually goes a little bit easier. 12 plus 1, we got 13. 5 and 2 is 7. 2 and negative 3 is negative 1. Bottom row, negative 4 plus 4 is actually 0. Going to cancel out there. 8 plus 3 is 11. And 1 plus negative 5 is negative 4. Good work. Now we said they need to be the same size. What happens if they're not? Okay, well, let's see. We got 12 plus 1. 12 plus 1 is 13. 5 plus 2 is 7. And then I have 2 plus... Oh, there's nothing there to add to 2. So that's why they have to be the same size. If they're not the same size, this 2 is not going to have a partner to add it to. So that one is not possible. Not possible. Good. Let's keep it moving. Scalar multiplication. It's like the distributive property. It's when you have a multiplier, a single number, integer usually, multiplier out in the front of a matrix, and you are just going to multiply it inside to everything. 2 times 1, 2 times 2, 2 times 3, 2 times 4, and our new one is 2, 4, 6, 8. Okay, pretty easy. Let's have you try that. Go ahead and push pause and try that on your own. Welcome back. Let's see how we did. We should be having 12, negative 3, 15, and 21. Good work. Now we're going to put it all together. We're going to do some scalar multiplication. And then we're going to combine them. We're going to add them up. So we will need some work shown for this one. So first we're going to do our scalar multiplication. And then we're going to add our two new matrices together to get our final answer matrix. Okay, so I'm going to get you started here. 3 times all of those. We should have 6, negative 9, 12, and 3. Okay, you go ahead and do the times 5, and then add those together. Go ahead and push pause and do that part on your own. Let's see how you did. 5 times 1, we got 5. 5 times 3 is 15. 5 times negative 2, we got negative 10. And 5 times 8 is 40. Next, we double check. Yep, they are the same size. We should be able to add these together. So 6 plus 5 is 11. Negative 9 plus 15, we have 6. 12 plus negative 10 is 2. And 3 plus 40 is 43. All right, so now we know how to add, subtract, and do scalar multiplication. Next comes the big one, multiplying two matrices together. With adding and subtracting, we could just visually inspect to make sure they were the same size. Okay, multiplying is a little bit different, and it's very important to be able to describe the size, and we're going to do that with its dimensions, rows by columns. Rows are side to side, and columns are up and down. And your little trick to remembering that is that columns, think of the decorative columns in the front of people's houses or the front of the White House, those tall columns that go up and down. Usually decorative. Some of them can be weight-bearing, but usually they're decorative. Okay, so this has 2 side-to-side rows and 1, 2, 3 up and down columns. So it would be a 2 by 3 matrix. In order to multiply matrices, the columns of the first matrix must be equal to the rows of the second matrix. And that's kind of weird to think about. It's easier just to write down the dimensions of the first one times the dimensions of the second one. If your middle numbers match, 3 with the 3, you can do it. You can multiply those. And the outside numbers will tell you the dimensions or the size of your answer matrix. So 2 by 3 times a 3 by 2 will make a 2 by 2 matrix. 2 by 3 times a 2 by 3, they are the exact same size. That would be perfect for adding and subtracting, but we cannot multiply them. Sad face. All right, yes, no, can you multiply them? And if it's yes, what would the answer size be? Go ahead and push pause and try these. Let's see how we're doing. Middle numbers match, that's a yes. Outside numbers tell me it's a 5 by 3 answer matrix. 3 by 2, 3 by 2. No, the middle numbers are different. 7 by 6, 6 by 6. Middle numbers match, that's a yes. And outside numbers tell me the answer matrix will be a 7 by 6. 2 by 4, 4 by 3, that's going to be a yes. And the outside numbers tell me the answer matrix is a 2 by 3. All right. Now let's actually do some multiplying. This looks pretty scary for being one problem. I broke this apart into all the little steps and gave each little step its own kind of line. If you were doing this problem on your own for homework, you would only have one line. So multiplying matrix times matrix is a little bit different than adding and subtracting and scalar multiplication. Okay, it's not spot to spot, which makes it a little bit confusing. Okay, so here we have a 2 by 2 times another 2 by 2. So yes, we can do it, and the answer will be another 2 by 2. So when we're multiplying two matrices together, we look at the rows of the first one multiplied with the columns of the second one. Okay, so we're going to go top row, left column is going to give us the answer in the top left spot. So top row of the first one times the left column in the second one. Okay, so we're going to take the first number in the top row times the first number in the left column, 1 times 3. And then we'll take the second number in that row times the second number in the column, 2 times negative 2. Okay, that's a 3 and a negative 4, which then gives us a negative 1 for our top left answer. All right. And now we're just going to repeat that process for the other 3 spots. Top row, right column to get the top right answer. Top row with the right column. So we have 1 times 1 plus 2 times 2. The first one with the first one, the second one with the second one. That's 1 plus 4, which is how we're going to get a 5 in that top right answer. We've got the top row filled in on the answer blank. Now let's drop down to the bottom row. So if I want the bottom left answer spot, we're going to need to use the bottom row with the left column. Okay, so we're going to be doing 3 times 3 and 4 times negative 2. Again, first one in the row times the first one in the column, second one in the row, second one in the column. That's 9 with a negative 8. That's going to be a positive 1 in the bottom left answer space. And our last one, we need the bottom right. Bottom row, right column. Three times 1, 4 times 2. That's a 3 plus an 8 for a total of 11 in the bottom right. Okay, if you get stuck on your homework, we can always come back to this little 4-minute window there and rewatch that. That should be pretty helpful. Let's flip it over and do some actual multiplying. Okay, we got a 2 by 2 and another 2 by 2. Okay, the middle numbers match, so it's a yes. The outside numbers tell me it's going to be a 2 by 2 for the answer as well. So I'm going to draw an oversized 2 by 2 matrix here for our work. And here will be our clean answer matrix. Okay, so we're going to go rows times columns. So we got 3 and -1 going with 2 and 5. So on the other side we had like 3 times 2, -1 times 5, and then I just wrote in what those numbers were. You could just write the numbers, like 3 times 2 is 6, and -1 and 5 is a -5. So this answer is a 1. 3 times 2 is 6. -1 times 5 is -5. Total of 1. Top row, right column. 3 times 5, we got 15. -1 times 1 is a -1. And then we'll have a 14 there. Okay, now we need the bottom, so we switch to the bottom row with the left column. 2 times 2 is 4. -2 times 5 is -10. 4, -10, -6 for the bottom left corner. And then our last one, bottom row, right column. 2 times 5 is 10. -2 and 1 is -2 for a total of 8. There it is, much cleaner and shorter than, all of that. It ends up just being one row of that because you're doing it all at once. Another one. Now we're getting into some that are different sizes. So this is 2 rows with 1 column. This is 1 row with 2 columns. The middle numbers match at 1, so yes we can, and the outside numbers are 2 by 2. So how are these 2 little dinky things going to multiply together to be a bigger matrix of 2 by 2? Remember, we're doing row times column. Well, there's only one number in the row and one number in the column, so this should be pretty easy. -4 times -3 is a positive 12. -4 times 1 is -4. Okay, bottom row. There's only one number in the bottom row, 7. 7 times -3, we got -21. 7 times 1 is 7. Pretty easy because there was only one number in each row and column. Okay, the next 2 problems are kind of related. Okay, note that they are the exact same matrices, just the order is flipped. So here we have 3 rows with 1 column times a matrix with 2 rows and 3 columns. Middle numbers don't match, so we cannot do this one. But what if we turn this around? Now it's a 2 by 3 is first times a 3 by 1. Middle numbers match, and the outside numbers are 2 by 1. 2 rows, 1 column. So up here we had 2 little ones that multiplied to be a bigger one. Here we have 2 bigger ones that multiply to be a little one. Okay, row times column. The whole row times the whole column. So we're going to do, before we've only had 2 things. Now there's 3 pieces. There's 3 things in the row and 3 things in the column. So we have 1 times 1 is 1, 3 times 2 is 6, and 5 times 3 is 15. And that should be 15 and 6 is 21, plus 1 more, 22. And then we do the bottom row times our column. 1 times 2 is 2, 4 times 2 is 8, and 6 times 3, 18. So we got 2, 8, 18. That's going to make 28. There you go, folks. So again, the primary focus for these multiplying ones should be the 2 by 2s times 2 by 2s. We will have some other ones here, some other shapes, other dimensions for good practice, but the ones you really want to focus on are those 2 by 2s. Okay? Thanks for watching, and good luck on that homework.